Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this is the calculation part. Okay, to calculate the pH of the acid and base. Okay, for this topic, you have to be able to calculate the pH of the strong acid, strong base, weak acid, weak base. This is what we will cover in this video. And then later you have to be able to calculate the pH of the salt solution and also the pH of the buffer solution. Okay, so let's look at how to calculate the pH of the strong acid and strong base first. So to calculate the pH of the strong acid is the simplest one, because we know that the strong acid 100% dissociate into ion. For example, if we have a HCl with a concentration of 0.01 molar, to calculate the pH, the basic we have to remember, pH is equal to negative log concentration of the H3O plus, or negative log concentration of the H plus ion. They are the same. Okay, so to calculate the pH, we have to know what is the concentration of the H3O plus first. Okay, so for this HCl with the concentration of 0.01 molar, during the dissociation it will turns to H plus and Cl minus. If we react it with water, HCl react with the H2O, then 100% dissociate to the H3O plus plus Cl minus. So if let's say we have 0.01 molar of HCl, H3O plus will be 0.01 molar as well, and same goes with the chloride ion. So now we have the concentration of the H3O plus. We can calculate the pH is equal to negative log H3O plus is equal to negative log 0.01. Then we press the calculator, then we'll get the answer is equal to 2. So the pH of 0.01 molar of the HCl is equal to 2. The next one, to calculate the pH of the strong base. Okay, so to calculate the pH, okay, we start with, for base, we have to start with calculate the pOH. To calculate the pOH, we have to know what is the concentration of the hydroxide ion that is liberated. Okay, so for strong base, it is the same as the strong acid just now. If we have sodium hydroxide, it will dissociate to the Na plus ion and OH minus ion. If initially we have 0.3 molar of sodium hydroxide, all these 3 molar will 100% dissociate to 0.3 molar of Na plus and 0.3 molar of the hydroxide ion. So this is the concentration of the OH minus. We can now calculate the pOH value is equal to negative log concentration of the hydroxide ion is equal to negative log 0.3. Press the calculator, then we'll get the answer is equal to 0.523. Then we know that pKw is equal to pH plus pOH. pKw is actually equal to 14. So if you want to know what is the pH, it is actually equal to 14 minus pOH. So 14 minus 0.523, then we'll get the pH of 0.3 molar of the sodium hydroxide is equal to 13.477 13.5. What if we have magnesium hydroxide? Okay, this is actually subscript. Okay, magnesium hydroxide. Okay, the same step as before to calculate the pH. For base, we have to calculate the pOH first. And then to get the pOH, we have to know what is the concentration of the hydroxide ion. Okay, so for magnesium hydroxide, MgOH2, during the dissociation, it will turn to Mg2 plus 2 hydroxide ion. So if we have 0.4 molar of the magnesium hydroxide, it will dissociate to 0.4 molar of magnesium 2 plus and 2 multiply with 0.4 molar because we have 2 hydroxide ion, 2 mole of hydroxide. So it is equal to 0.8 molar. So now check, we already have the concentration of the hydroxide ion. We can calculate the pOH is equal to negative log OH minus, which is equal to negative log 0.8. So the pOH is equal to 0.0969. So with the pOH, we can calculate our pH, which is pKw minus pOH, which is equal to 14 minus 0.0969 is equal to 13.9. So the pH of magnesium hydroxide 0.4 molar is equal to 13.9. Okay, it is simple for strong acid and strong base because they are 100% dissociate. Now we move to the weak acid and weak base. This is when we have to apply all the information that we have learned in the equilibrium before. We have to construct the ice table and then get the concentration of the H3O plus or hydroxide ion. So we have 0.8 molar of the acetic acid, CH3COOH, and we know the acetic acid is one of the weak acid, which is not 100% dissociate into ion. And even when we get an acid and the Ka is given, we know that it is a weak acid. Because if you have a strong acid, there is no Ka and it is 100% dissociate. So to determine the pH of a weak acid, okay, we have to bear in mind that if initially we have 0.8 molar of the acetic acid, we'll never get 0.8 molar or the same concentration of the hydroxonium ion that is liberated, because this is a weak acid that is partially ionized. Okay, so let's write the target. We want to calculate the pH of the solution. So to calculate the pH of the solution, we have to have the concentration of the H3O plus that is liberated. So to get the concentration of the H3O plus that will be produced or liberated by the acetic acid during the dissociation, we have to construct the ice table. So our ice table will be CH3COOH react with the H2O, reversible arrow because this is a reversible reaction, turns to acetate ion, and also H3O plus. Concentration initial, this is the same as what we have done in equilibrium topic. Initial concentration, acetic acid is 0.8 molar, dash for H2O, and then 0 for acetate ion and 0 for the H3O plus. Concentration changes during the reaction is minus X for acetic acid, dash plus X for acetate plus X for the H3O plus. So that when it is at the equilibrium, concentration will be 0.8 minus X, X and X. So remember, when we want to determine the H3O plus, okay, means that we have to solve what is the X value. And how to solve the X value is by using the Ka that is given 1.8 times 10 negative 5. So write the Ka expression. So it is equal to the concentration of the acetate multiply with the concentration of the H3O plus over concentration of the acetic acid. Okay, and then the Ka is given as 1.8 times 10 negative 5. So it is equal to, plug in this, so we have X square over 0.8 minus X. So to solve X, okay, by looking at the Ka value, we know that we have 10 power of negative 5 and it is considered as small Ka value or small k value. So we can make assumption in order for us to simplify our calculation. So the assumption, since Ka is too small, so 0.8 minus X is almost equal to 0.8. After we write this assumption, then we can proceed with the calculation. So the calculation will proceed as 1.8 times 10 negative 5 is equal to X squared over 0.8 only. So we solve our X. X is equal to square root 1.8 times 10 negative 5 multiply with the 0.8, and lastly we get the answer is equal to 3.8 times 10 negative 3. So this value is actually equal to the concentration of the H3O plus, because X is the concentration of the H3O plus at the equilibrium. It is also the concentration of the acetate ion, and we also can get the concentration of the acetic acid here. Okay, so now we already have the H3O plus concentration. We can calculate our pH. pH is equal to negative log concentration of the H3O plus, which is equal to negative log 3.8 times 10 negative 3, and finally we get the pH of the solution is equal to 2.42. So with this, we have solved our pH calculation for weak acid. So remember, for weak acid and weak base, okay, to get their pH, we cannot simply take their concentration because it will not 100% dissociates into ion. They are partially ionized, so we have to construct the ice table and solve the X value.